Okay. Do you hear me? Yes. Okay. Sorry for the technical difficulties. Okay. Thank you, Pierluigi, for the word. I am not a doctor yet, though. Thank you. And thank you, Milena and the team, for again organizing a wonderful conference. This is my second time at WeBIOPATR, and it's again very nice. So today I'll be talking about our research we did, our sampling of about 100 participants in Ljubljana. And this is a small nugget of information that we're trying to get from this data set, and it is basically about an assessment of increased individual level exposure to PM during periods of atmospheric thermal inversions. Okay. So in December 9th, 1952, I think a lot of us already heard about this, but there was
Okay, we go to Zoom. Okay.
Through Zoom, yes, yes.
Continue.
Yeah, okay. Yes, so this event, the smog event in London, it happened for a few days in 1952 in December. It was a combination of cold, moist air and an anticyclone that happened in the London basin, and it caused great smog. So because there were lower temperatures and in that time, because of the inversion, it caused more people started to burn more coal, and the air kept getting worse and worse. About 4,000 people died as a direct result. Now the estimates are about 10 to 12,000, and 100,000 more had respiratory tract effects. As there were estimates there, it was about 4,500 micrograms of PM per cubic meter. And it led to several changes in practices and regulations, including the Clean Air Act of 1956 in the UK. So this was an event of thermal inversion, and the Ljubljana basin is a basin. So basically it has several characteristics that are close to that in London, though it's not close to the sea, but still it is a concave shape. And atmospheric thermal inversions happen in Ljubljana. They are a consequence of atypical temperature gradients, because usually the temperature goes from the ground up, it gets colder. But atmospheric thermal inversions, that is inverted, as the name suggests, and there is a cap produced that reduces the fusion of dust, smoke, and other air pollutants, and it makes the air much worse in the basin itself. So this is a scene quite common in Ljubljana, and people from Ljubljana, if any of them are also following this presentation, are very, very familiar with this view, where the air is quite thick and smoky and very dark and cold in the basin. But if you go just a few hundred meters outside of Ljubljana, it gets nice and warm and sunny. For Ljubljana itself, a few conditions, well, this goes for inversions in general, but the long wave radiation from the ground must surpass the short wave radiation from the sun. The conditions might be windless or still, so it doesn't blow away all of the smoke and dust and so on. And the length of time is quite important, because if it's just a few hours, that is not enough for a real true inversion to happen in a way that it would affect air pollution and air quality. In Ljubljana, there is a unique set of conditions, because Ljubljana, as you saw before, it has a concave shape, has extended periods of anticyclones, and there is a lot of drag associated with the complex topography. These results in foggy days and a lot of ATIs during October and February. This in turn, of course, causes a buildup of PM. So the main sources of Ljubljana are probably very similar to a lot of those that we mentioned yesterday, but it's traffic, of course, because Ljubljana is a major mobility hub for around 500,000 people in central Slovenia. And Slovenia is still one of the top countries in EU by car usage, which means that a lot of people come by car to the city. The city center is close to traffic, but that is just a small, very small part of the city. Ljubljana itself and the Ljubljana basin is much, much bigger than that. And of course, individual wood burning units. That is very prevalent has become more prevalent in the past decade as gas and fuel oil became more expensive due to different taxes and things like that. And Slovenia has a lot of wood, of course, a lot of trees, and the wood is cheap. So, and a thing that is very common in Slovenia is for people not to burn like proper logs, but just anything that resembles wood. I must say that although this is my profession, I must say that my relatives do this quite very much during the winter. They just burn old chairs and cupboards and so on, which reduces the air quality significantly during winter. So going to our sampling campaign, it was Icarus 2020 project, and we had about 85 participants in Ljubljana who were equipped with these kinds of particulate matter sensors. They were wearing them all the time for about a week in February to March, and then in April and May, so a heating and non-heating season. They also filled out time activity diaries with 1 hour data. So for each hour throughout the week, they had to write down what they did and where they were. But for this particular study or exploration that I'm showing you here, they had to meet 4 criteria. So the first one was that they were part of the winter sampling period. That is the time that most of these inversions happen. The data had to be available for that time because these are low-cost sensors, and their low-cost sensors had to work well. And as we all know here that we deal with some low-cost devices, they are prone to, well, data gaps and just malfunctions and erroneous data, and they just stop working for no reason and so on. So this was another condition, and they had to have full-time activity diaries. That's also quite important because they at least have to designate if they were outdoors or indoors. We got a lot of data from our Environmental Protection Agency, and it was a series of data points. So here on this plot, you can see differences between Ljubljana station, so that's about 300 meters elevation, and the other station, which is about 600, between 600 and 700 meters. And these differences show inversions. So as you can see from early February to early March, these inversions happen quite often, especially during the morning. But this window between the 16th and 22nd had really explicit temperature difference between lower and upper ground, and really explicit inversions. This is also seen here, where you can see the average temperature for Ljubljana, and you can see that the temperature actually rose a bit because of the cap, but then after the wind came and the temperature changed, then it dropped down again. This is also clear here. We can see wind speeds that picked up on the 22nd and 23rd and dispersed the inversion. And this is probably the most important data point here, where you can see PM10, which rose quite significantly during the first days of the inversion. And then as the wind picked up and the inversion broke and the cap broke, the concentrations fell quite rapidly in the next few days. This is really important for this plot. So this is basically the results now, as this is just a preliminary exploration. I didn't delve really deep into the results, but there were some very, very interesting preliminary results. Here, as you can see, the indoor results for people that were during that time were around 40 micrograms per cubic meter, but outdoors they were above 70. And the main point here is that there was a lot of difference here. So it was about 32 micrograms per cubic meter. And this encompasses all of their activities. So biking, walking, or running outdoors, or cooking, cleaning, any activity indoors. So this encompasses their entire days, weeks, so all of the data that we have. And this is exposure after the atmospheric thermal inversion. So of course, the concentrations are much lower, as you would expect. But one of the main differences here is the delta. So it's just 2 micrograms in contrast to the data before where it was 32. Because, of course, the concentrations are lower. But one of the important facts here is that activities themselves indoors can raise concentrations. So these activities that, for example, like there was this one person where I looked at their data and their concentrations rose quite a lot when they were playing with their child, for example. There is suspension of dust and cleaning and so on that can cause concentrations indoors to rise and be basically very similar to those outdoors when the outdoor concentrations are lower. So while participants also recorded all of their other activities such as sleeping, resting, cooking, and so on, especially smoking indoors, that's of course known to raise concentrations a lot. But the thing is that even when we take account in these activities, the trends were still quite similar. So indoor activities showed less difference to outdoors in the period after the ATIs. Of course, this is just preliminary, so more analysis is necessary here to show if these differences are significant and if we can see a really clear trend. So the main conclusions for this is that subalpine basins, as we know, are prone to atmospheric thermal inversions, and they have negative effects on air quality and elevate particulate matter levels, which is especially caused by wood burning and traffic. These individual level measurements, as we conducted here, offer some unique and detailed insights into specific activities and micro locations, because it's important that we get a holistic look at how a person is exposed to PM, not just average concentrations for the entire city, because specific micro locations of movement around can impact their exposure quite significantly, especially during ATIs, as we can show here. Of course, ATIs here are just a special occurrence. Of course, there's nothing significant about just the thermal inversion, but the pollution that comes with it is that factor that causes this change in exposure on an individual level. So outside of ATIs, specific activities cause the PM concentrations indoors to rise. And that is the main outtake of this presentation that I would like to focus, and that these individual level measurements are really necessary to get the complete and detailed exposure profile. So I would like to acknowledge all of the entities that helped in this, from the Icarus project and the European Union that's supported it, to my institute and college, and of course to the public research agency. The last time it was at WeBIOPATR, I talked about intake dose and different models, and I'm glad to say that that paper was actually published after that data was collected and curated. And if you want any more information, if you have any questions, or if you want to follow my work, here is everywhere I'm present. So please, you can contact me.
So thank you very much,
Rock, for
Yes.
So thank you, Rock, for your well-designed study and your brilliant presentation, aesthetically very nice. I see that there are some questions. Saverio De Vito is asking, is complimenting himself with you. So really nice work, congrats. I can't ask a question by voice. Anyway, Have the sensor undergone a calibration stage? Do you measure only the indoor-outdoor status or even the path? How is the participation? Do they abide to take sensor always with them? First question from Saverio De Vito, Enea, Portici, Napoli. Please, Rock.
Okay, thank you. Thank you, Saverio, for the question. The sensors were calibrated and validated inside of the Icarus project in Greece, but later we did additional validation in Ljubljana and comparing it to a GRIM device, so kind of a reference unit that we could see that it kind of that they at least have a similar trend and that the results are similar. And they showed really good. They have, you probably know the sensor. It's the Plant Hour PMS 5003, I think. And those sensors are usually quite good. The other question is, do you measure only indoor-outdoor sensors or even the path? So the thing is that we did have GPS in the sensor, so we could look at the path. And that is the next stage when we will be actually looking at precise indoor-outdoor. But here it was based only on participants and them logging indoor or outdoor. And then I made another change by excluding data above 20 degrees centigrade if it was outdoor, and below 20 if it was, no, other way around. Yeah, but yes, you know what I mean. So the temperature also gave me some insight if they were indoor or outdoor. And yes, participants had to have the sensor with them the entire time. So the entire 7 days, anywhere they go. But it wasn't necessary for them to have it on them. For example, if they were in a conference room like this, but they could have it on the desk or on that desk, for example. So it measured in the room, but not around the person, I should say. So it was still, that's still, yeah, exactly. I hope I answered your question.
Thanks for your work. Also,
So I was just reading, thank you for your work also in the name of my friends in Ljubljana. Much sought assessment, congrats. Perfect. Any other question? Oh.
So it is a really nice study. How many cities participate in a similar one? Is it only in Ljubljana or somewhere else? Because I know that Icarus project was a big one, and it will be interesting for us to know how long it was calibrated in at Greece, and how long in Ljubljana. So that is my questions in a moment, maybe later more.
Great, thank you, Milena. I think there were 7 cities altogether, but the thing is that this was done with only Ljubljana data because I have the Ljubljana data, and yeah, and the thing is that we have been collaborating with some of the other partners from the Icarus project, but as you know, from these kinds of projects, some of them are more responsive than others, and it's easier to work with some of them and not so. So this is why I focused on this data. But in the future, I hope to collaborate with other cities because we also have partners in Milan and Madrid and Brno and Thessaloniki and so on. And it would be really interesting to see some comparison between the cities. Regarding the calibration and validation, I know for Ljubljana, we did the validation for 1 week. And then another one with a special smoking event indoors, so we could see the high values. But for Greece, I don't know. I don't have that information with me. I think it is, we got those sensors, and as we understood, they were calibrated and validated and so on, because a company made them for the project. That data is, I think it is included in one of the deliverables from the project, but I don't have the details. So I can't.
The Icarus is finished, yes?
Yes, Icarus was finished. Icarus was finished last year.
That studies are performed in other cities. That studies similar like in Ljubljana. The collection of data in other cities are also performed.
Yes, the data was collected also in these cities, but nobody is obliged to do anything with the data as long as it's collected. But we're trying to find something out and get some information from all of this data collected.
I think the same one.
Sensor in framework of UNICEF study that Lydia yesterday talked about. That is why I asked how long it was that calibration at Ljubljana, and but it was how long? I miss how long you have that collection. How long you collected data? How long campaign was? How long?
So the entire camp. So it was like for 3-4 months, but
4 months.
yeah, but it was for 1 week for every person. Yeah.
Thank you, Novak.